Hey guys, today we're going to look at the difference between what's an observation and what's an inference. So our question for today is, what's the difference between an observation and an inference? First of all, we're going to look at observations. Hopefully you've learned somewhere in the past that observations, basically observations are information that you collect using your 5 senses. Now think about that for a second. What are your 5 senses? Well, you have what you see, you have anything that you smell, anything you taste, anything you hear, and anything that you can touch. Those are your 5 senses, and that's how you bring information in. Once you bring that information into your brain kind of works it all around and comes up with an idea about what's happening. Okay, but first we're going to look at information. All right, we're going to collect some information. So you guys stay right there. I will be right back, and I'm going to get something super cool for us to collect information on. All right, guys, I'm back. I got 2 marshmallows here. I got this marshmallow and this marshmallow. And I need to make some observations about these marshmallows and then make some inferences. Now, my observations need to be scientific. Remember what I said. Observations are using your 5 senses. Now, I can say, and I can feel it, this marshmallow is colder than this marshmallow. This marshmallow is pretty warm. But I want to be a little more scientific than that. So I got this really cool thermometer. So I am going to take my cold marshmallow and I'm going to put my thermometer against my cold marshmallow. And it's giving me a reading of 22.3 degrees Celsius. Now, Celsius is what we use in science. All right, I'm going to take my same thermometer, and I'm going to put my thermometer into the other marshmallow. Wow, you should see it going up. The other marshmallow is at 44.5 degrees Celsius. So there's a temperature difference, and there's a, look at that, there's a huge difference in how stringy it is. Is that a science term, stringy? If I take this marshmallow and pull it up, it feels very sticky. If I take this marshmallow, I can't do that. This marshmallow is much more solid. Now, they're both the same color. They're both white. So let's see. I did a touch, how they feel. I can see that they look different. One is still, you know, a marshmallow shape that we would see in the store in the bag, and the other one is much more flat. You can take a look at that. The smell is different. The smell is a lot different. This smells like a marshmallow, and this smells like a cooked marshmallow. It smells a little more burnt, if that makes sense. And I went ahead and put some chocolate underneath there because this is going to be my snack in a few minutes. And believe it or not, you can hear a difference. I don't hear anything from this one, but I hear little bits of popping from this one. And then, of course, in the name of science, I'll do a taste test. So there's that one. This one's a lot more like gum. It It gets really hard really fast. This one stayed a lot softer. So that's a big difference between the two of them. So if I had to say, my inference of what I think is happening here, because remember, an inference is an idea of what you think is happening based on your observations. My inference would be that this marshmallow was cooked and this marshmallow was not. And that's exactly what happened. It was actually microwaved, not so much cooked. All right, let's practice our observation skills. I'm going to throw up a picture here for you. And what I want you to do is write down some observations. Okay? Write down some observations for this picture. Okay, so when we're dealing with pictures, it's really hard to use all of our 5 senses to make observations because we're dealing with a picture. So when we look at this picture, first of all, it's hilariously funny. Second of all, you have to take your time and look around and see what's going on. So you have a lot of sea otters. I think if we counted them, let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, at least 13 sea otters. They're floating in the water. Are they floating, or is that an inference of mine? They're in the water. We don't know if they're floating. We know that there's a dog. And we know that the dog's eyes are open wide. We can't really say that the dog is surprised, or we can't say that the dog is scared, because if we say that, we're making an inference. We don't know how that dog feels. We can just say what we see. So you have to make those observations just based on the information that you're given. His eyes are wide open. He's standing tall out of the water. He's standing in the middle of all the otters. And then from that, we can make logical inferences. We might be able to say, the dog is scared. The dog popped up in the wrong place. Why don't you come up with some logical inferences that you think would be reasonable for this picture? Alright, now let's move on to another picture. Take a look at this picture. Let's say that these two are your friends, and they're standing at their locker and they're talking. I bet this has happened to you sometime. You make some observations. You're walking down the hallway, you see your two friends talking, and they start laughing, and they look over at you, turn back to each other, and start whispering. You made some observations there. You observed your friends. They were laughing, they were talking, they were looking at you, and they were whispering. So you took all that information, all those observations, and you made the inference that they were talking about you. And suddenly you're hurt. Your feelings are hurt, you're upset. So now you're probably starting to see how we make observations every single day. And sometimes we don't make the best inferences because we don't take the time to gather all the information. So what if your friends weren't actually talking about you in a gossipy drama kind of way? What if they were talking about your surprise birthday party this weekend? You didn't know about it. You didn't know your mom had been planning it. You didn't know it was a big deal. All your friends were excited. Meanwhile, you're standing at your locker, all upset. ready to stir up some drama, and you completely misinterpreted the situation. Your inferences were wrong because you didn't stop to get enough information. Same thing can happen in science. If you don't get all the observations that you need and take the time to get as many observations as you possibly can, your inferences can be wrong. That's bad news if you're a scientist. Scientists do important work, and they have to get their observations right. That's why they observe so much. You can't observe one afternoon and suddenly cure cancer. It doesn't work like that. You have to do tons of observations over time, and then put all that together to make solid inferences. That's so incredibly important. Probably one of the most famous mistakes, or scientific mistakes, that you can probably think of is if we all think back to Christopher Columbus. If you'll remember, he thought the earth was flat. With good reason. I mean, think about it. If you're in a ship and you're sailing out to sea, and as far away as you can look, all the observations that you're making are telling you that everything's flat. I mean, all of the data that you're gathering from all of your five senses are telling you that the world is flat. That seems like a good inference to make. But he needed more data. And with later scientific discoveries and theories of math, we found out that the world is in fact round. That's huge. And that was all based on observations. And it was an incredibly incorrect inference. All right, so let's move on. Okay guys, so go ahead and make some observations about what I have in my hand here. And after you've made, say, 2 observations, go ahead and make an inference. Oh, wait. A little bit of music. Got your observations? Got your inference. Think you know what this is? You sure? Well, maybe you were wrong.